now that we know what point-slope form is, how can I turn it into slope-intercept form? And here is the beauty of me teaching you all this linear stuff, because I shouldn't have to teach this to you right now. You should, if you remembered what you did in 4.1 and 4.2 and 4.3 and Unit 2 solving equations, if I say y minus 5 is equal to 2 times x plus 1. If I say, hey, this is point slope, put it into slope intercept, I should be able to put my pencil down and say go, and you should be able to do it. Why? Because what does slope intercept mean? It's a fancy way of saying get y alone. So what is your first instinct to do when you look at that equation? I see parentheses. Parentheses usually mean I have to do what? Distribute. I have to use the distributive property. What should I distribute? Oh, the number in front of the parentheses. Do it. Do step 1 right now. Distribute it. This is where your rock star equation solving skills come into play. This is also where, if you've not been with us and on the ball up to this point, where it starts to fall apart for you. Because I am relying on tons and tons of prior knowledge right here. So now, all I got to do is to get y alone is get rid of that pesky, now I got to look at it. I know, kids are like confused. I'm not looking at it as point slope form anymore. I know I just said it's a positive 5. What do you usually do to solve that equation? You do a plus 5. And so y is equal to 2x plus 7. That was not hard at all, was it? It was like a quick little snafu. I distributed and I canceled out the constant and I have slope-intercept form. So I have point-slope form here and I turned it into slope-intercept form. Here's what I need you to understand. These are the same lines. They look different, but they're the same lines. If I were to plot them on a graph like I will in a second, they're the exact same line. One will be on top of the other one, okay? So we know how to graph in slope-intercept form. Let's start at what? This is the B where we begin. Let's start at plus 7 and let's do what? Up 2 over 1. Let's do it. So here's my plus 7. Up 2 over 1. We can go down 2 and left 1 if we need to add a couple points. So that is my, I need my desk. I need a drawer in my desk. So there is my slope-intercept. All right. This is also another one of these where I'm sitting up here crossing my fingers saying, please, please, please. If I just gave you that and asked you to graph it, talk at your table for a minute about what you could do. That does not turn it into slope-intercept form. You can't turn it into slope-intercept form. How could you graph from point-slope form? You need a place to start, and you need somewhere to go. Go. Take a minute. Hint, hint. It has something to do with what we just did about 10 minutes ago by pulling out vital information from point-slope form. The doy. Yeah. Yes, it tells you where to start and it tells you where to go. You just got to do a little detective work. By the way, if you're converting and your slope is one thing in one of the equations and something different in the other, you messed up. Because the slope's not going to change, is it? The slope is the same regardless of what line. What point will this line go through? -1, comma, +5, right? So now if I needed to graph it, I don't have a B, I don't have this +7, but I have a different place to start. And that is what? -1, +5. Oh, what do you know? Look at. And where do I go from there? up 2 over 1. I just started in a different spot. So the most important thing I need you to know, we're converting back and forth between all these forms. When you graph all three, they're all the same line still, just with a different name, okay? All right, try this one for me. Y minus or plus 2 is equal to 1/3 times x minus 6. Go, try it. Distributing that fraction, that pesky third. Taking a third of something just means dividing it by 3. That's it. Do you have minus 2 there? I hope, because what's a third of 6? If you don't know, then you got to go old school. You got to do some good old cross-canceling. Okay? Yes. Yes.
So you put x here 1/3 x. And you put x divided by 3.
Yes.
Okay.
I'm so glad that Alex just said that. Everybody just listen. X over 3 is the exact same thing as 1/3 x, because the x can go in the denominator or as separate. It just can't go in the or it can go in the numerator. Sorry. All right, almost done. We're wrapping it up. There you go. That line and that line are the same. Yes. Okay. That's from point slope to slope intercept. I have one more thing to show you, and we are done. I want you to go the other way, because when I give you this column, what if you start with this? You need to be able to go all the different directions. So watch this. Slope intercept to point slope. People think that this is the hardest one. It's because they don't know where to look. And they're just looking for, they're not thinking about it. This is another one. Oh, I don't really want to tell you, and I'm not going to. What do you need to put it in point slope form? You need a point and you need the slope. Go. Discuss. How could I make this look like this? You got everything you need right there. There's like zero math to be done. Okay, the easy part's there. I know where to find my slope. It's staring me in the face. Ah, that point though. Yes, that's actually your only option right now. She said, couldn't we use this beginning value? Yeah, but a lot of people look at that and they see one number and they don't assume that that one number is actually a place on a grid. And if I were to ask you to graph this, wouldn't you start right here? If it's a point, it's got 2 coordinates. You just have to figure out what those coordinates are. And here's the really cool part. Is that 0, 3 or 3, 0? It's 0, 3. There's my point. And I put the x, which is 0 with the 0, and the 3 here. You can leave that 0. You do not have to distribute through. That is point slope form. So hey, guess what? When you have slope intercept form, and I ask you to put it in point slope form, is that number in that second spot always going to be a 0? Yeah, if you're using the y-intercept. So let's try one more. Y equals 1/3 x minus 10. Go. Write that equation in point slope form.
Are all 3 of these going to get switched
Yes. It's going to have columns. It's going to have all different kinds of sets of directions. So you have to really understand know what each form is. So it may be helpful for you to kind of write out what you're dealing with over here. I know the slope is a third. If I were to graph this old school style, I would go all the way down here to negative 10. Oh, and the name of that point happens to be 0, comma, negative 10. So I'm going to say y. Let's try to do it without writing it out like that. Y plus 10 is equal to 1/3 times x minus 0. And if that's a 0, I don't care if it's a minus or a plus. It doesn't matter. But okay, so I got one more thing to show you, and then we're done. What if I said to you, go from point slope to standard form? Y minus 3 equals 2 times x plus 1. What? Use your noggins for a second. Okay, here's a little hint. If I need to go to the mall, but I don't have any gas in my car, I have to make a pit stop where? The gas station, and then I can get to the mall. I have just enough to get to the gas station. So, how are you going to go from point slope to standard form? Go, discuss it. You got to make a pit stop somewhere. Is it really easy to go from one of the forms we already know to standard form? We learned it yesterday. Think about where you got to go first. Yes, Gabby, yes. Think about where you got to stop first. And this is called when it all comes together, right?
I think I got it.
Because you know, standard form looks like this. Standard form is kind of like different, right? So who thinks they got it? First you have to do what, Hallie? Yes. Y minus 3 is equal to 2x plus 2 plus 3 plus 3. Y is equal to 2x plus 5. Stay with me. We're almost done. Hey, she asked me for standard form. That's not standard form. That's slope-intercept form. But when it's in slope-intercept form, isn't it really easy to put it in a standard form? So you had to make a little pit stop, didn't you? So now I got to get rid of this just like we did yesterday. That's why I teach you all these things, because they all are related. And I'm almost there. Because I need to do what? Get rid of that negative. And my final answer is positive 2x minus 2y equals negative 5. I just want to show you something so we can be done, the beauty of this problem. I went from one form to another to another. Do you see how they are all related? They are all the same line when plotted on a coordinate.